Now, these are behaviors of intruders. So basically, this will allow someone watching the traffic to tell that there is an intrusion going on. Okay. So among the indications, so if an intruder is trying to select the target using IP lookup tools. What are those IP lookup tools?
The local DNS cache?
No.
Network map.
Network map can be, he is trying to choose a target, a victim, by scan. Map network for accessible services, that's a bit different. So you can find out which services is running in a certain host by this is basically done by port scan, right? So if this is among the behavior that you can observe in the network. You can see that there is port scanning. You can see that there is an IP scanning. Okay, so these are indicators of an intrusion being done. Identify potential vulnerable services, same thing. Brute force passwords, in particular here, online brute forcing. Okay, online brute forcing. We're gonna cover this in the next lecture. It's the difference between online and offline. So online brute forcing is basically trying to guess through the network. Okay, and this involves sending a lot of traffic. Install remote administration tools. This is mainly for malware. Wait for admin to log on and capture password. So all these, this is about detection. Okay. So these are common behavior of intrusions. Okay, that can be used for detection. Okay. So for example, in an intrusion detection system, we're gonna see it. You have signature for almost each one of these. A signature, a pattern. Okay. So if, for example, you have if a port scan is being done, the intrusion detection system will have a signature, a pattern. Okay. And it will try to match that pattern inside the captured traffic. If it can see that particular pattern being observed in the network, it can raise an alert or raise a flag. Yeah. So these are the list of network intrusions we're gonna see. We're gonna discuss them one by one. So it's an extensive list. I think most of you are familiar with most of them. Okay, but I will go through them one by one. So the first one is port mirroring. So port mirroring, basically, I think the first three network intrusions are about capturing the traffic. Okay, so capturing the traffic being sent in the network. Okay, so the first technique to capture the traffic is port mirroring. So you have in the network devices, the switches or the routers, you have an extra port that will be here. That will send all the packets going through that network device to some monitoring computer. So this is you need to implement at the physical level. Basically, you need to have a network device with that extra port configured to forward all the packets to a monitoring computer. Okay. So this can be used by the gateway or a router inside the network to observe everything. Okay.
It's legal, right?
Legal. In an organization, organization, if it tells everybody that it is doing it is legal. But if someone is replacing a network device with a device that has that mirroring port, and he is doing it without letting everybody knows, this is not legal. Yeah. Network tap. So network tap is a particular device installed in the network that will explicitly capture the traffic. Okay, and it will be linked to some monitoring computer. So it's not a port in a network, another network device is specific small device, a tap, it's known, a tap that will forward all the traffic flowing to some monitoring computers. And now tap here doesn't stand for any, it's not an acronym. Tapping, it means observing all the paths there. Okay.
Is it a device, a physical device again?
Yeah, it's a physical device. Yeah, it's physical. So that's placed in the network.
So what's the difference between it and the previous one?
Sorry?
So the port mirroring.
Port mirroring, this is a port inside a network device, a router or switch or an existing network device. You will configure one particular port in that network device to forward it. But here it's a tap. So the difference here, you can install this tap. You see, for example, some cable which is exposed. Okay, you just place the network tap there. Okay, so this is the next type of network sniffing, which is traffic sniffing. And traffic sniffing can be done at the hardware level or at the software level. So at the software level, you know how this is done. Which, you use a software sniffer like Wireshark, but of course the software sniffer needs to be placed in a location in the network that has access to everything you want to observe. Okay, it is related, right? So you need to place it somewhere where all the traffic is flowing. Okay. Now here it's talking about how you can sniff the network using physical tricks. So just steps and analysis can be used to also network traffic. So attackers can access the one network in the following ways. They can use false ceilings. So false ceilings are these. It's not real ceiling. It's you can I think in other rooms it's like tiles, like squares. You can remove one and then see the cables, and then you can access the cables and install whatever you need there. False ceilings, exposed wirings. So exposed wiring, sometimes in the labs we see wires exposed. Same thing, you can plug in the device there. And protected RG45 jacks. So sometimes in the walls you have outlets for RG45. RG45 is the Ethernet connector. Okay. So all these, this is related basically to physical security. So if you need to protect your network from an unload observation, you need to protect these. Okay. False ceilings, exposed wires, etc. One way of intrusion, network intrusion, is to take advantage or compromise a network device. I think there is a tutorial session about this. Okay, compromising network devices. So here you have a network, a lot of network devices like the routers, the switches, all that. Okay. You can compromise those network devices by using a default password. Okay, so very common practice that whenever we configure the network device, we leave the default password as is. We don't change it, like admin. Okay, so it's very common that the password stays like that, admin or root. Okay, and basically this is it's a very common way to compromise a network. There are websites that will list all the default passwords according to the brand of the network device. So you have Cisco brand stuff. You will have the corresponding default user and password. Okay. So user account on the device. So basically, if you have access to the network device software system, you know what you can do. You can change the password. You can compromise completely the network. You can install a mirroring port. Okay, you can configure a port to mirror all the traffic. Yeah.
Spoofing
Spoofing.
inside the router because maybe there's cache poisoning, DNS poisoning.
No, we'll come to that. We'll come to that. Another vulnerability that targets the network devices is backdoors. So here again is hardware, hardware or software. So the idea here is that the network device itself, it has a backdoor, either at the hardware level or at the software level. What is a backdoor? An access point or an entry point to the device which is not exposed, which is not known, basically known only by the attacker. Okay. Now, when you buy a network device, it is basically most of the time it's made in China or made in Taiwan and you cannot certify all of the hardware devices, the chips, the circuits, etc. You cannot certify. Okay, you buy it, that's it. You will use it. Okay. Now, it's very common that those devices, they contain backdoors, and basically the manufacturer leaves an entry point, an access point, so that it can compromise it whenever it wants. Basically. Okay, it's very common. Okay, so sorry.
It's like master password.
Master password, yes, but it might be more straightforward than that. For example, it might be some if it is a router, for example, a router which is put on the boundaries of internet, for example. It's a gateway to internet in that organization. It might be configured to forward some particular information to some IP. Okay, very easy to do. Okay, backdoors can be created by virus or by a programmer of the software of the device. So the software itself it has this backdoor or built into the hardware chips. And talking about this, I think in 2008, U.S. military services, they found out that some of the devices, they are doing some strange connections and traffic, and it turns out that the hardware, some of the components of the network devices they were using are manufactured in China and in other locations. So those chips, they contained backdoors. So these chips can contain backdoors or switches, etc. So this is why I think from that point on, the Pentagon, they decided to not use any chip manufactured outside the US. Okay. So we are dependent in technology. We are dependent on. We buy equipment from outside, the chips. We don't manufacture these chips here. So we are exposed, basically. We are completely exposed. Even Windows and all the operating system, etc. We are completely. We don't know what's happening in the hardware we are using and the software. US can't afford to say I will not use something manufactured outside, but we poor people, we can't afford that, right?
We can use open source systems and
even open source, they have backdoors.
Yeah. If they target you, you will not escape it. Next attack, everybody knows the denial of service. So denial of service is an attempt to consume network resources so that the network or its devices cannot respond to legitimate requests. So the very simple example is the SYN flood attack. So SYN flood attack, basically, it will try to open the three-way handshake of TCP. And three-way handshake, you remember, it's composed of 3 steps. Okay, SYN, ARP, and then ARP. Okay, so if a computer starts a TCP connection with a SYN, then the server enters with a SYN ACK. Now the server will be allocating some resources, and then it will be in a pending state until it receives the ACK. So it's in pending states. If that computer does not send the ACK, the third step of the 3-1 check, it will stay in a pending state. So the resources will be allocated, but it will stay like that. Okay. So if you repeat that number of times, large number of times, the resources and the server will be exhausted. This is the idea basically of SYN flow, denial of service. And the same idea can be used in other protocols. Okay. And distributed denial of service, it's the same as DOS, but the attack is launched from a huge number of IPs or hosts at the same time. Okay. So it may use hundreds or thousands of zombie computers in the botnet to float a device with requests. I will show you how this can be done. Okay. Sorry? It's a network attack. It's a network attack. It's considered as an intrusion. Yeah. Because the intrusion, the definition, as we understand, is just to go inside. But here is to interfere with the normal operation of the network. Okay. Intrusion is damaging. You will intrude, you will do something harmful. Spoofing. Spoofing basically it's impersonation. So basically, if you send a packet, if the receiver wants to know your identity, he will check the source IP or the source address of the inside the packet. So spoofing consists in changing that, okay? Changing the source address, or basically to hide your identity. You do something and you make it appear as if somebody else did it. Okay. So attacker pretends to be someone else. Malicious action will be attributed to another user. Spoof the network address of another. Spoof a wireless router to intercept the traffic. If you can impersonate as a wireless router, and you will receive all the traffic. And everybody who wants to connect, to communicate with anybody else will connect to that router. Now there is a small problem with spoofing. If you send a packet to a certain destination, okay, and you change the source address, do you see a problem here?
Change your source address.
What's the problem?
The reply will want to.
Yeah. If that destination will respond, it will not get to you. It will go to that whatever IP you used to replace that. So when spoofing is done, this point should be taken into consideration. There are ways to bypass that. Okay, and even though the source IP is different, you can find and you can get an idea about the response of the destination. Okay, these are the advantages, but it's important to notice. Okay, spoofing, it will be hard to get an answer or a response from that destination. Okay. Man in the middle. So man in the middle, also very general type of network attack. So man in the middle, the attacker will try to place himself between the sender and receiver. We saw one variant in the cryptography part. Diffie-Hellman. Yeah. So this is the idea. So if an attacker can place himself between the sender and receiver, he will get access to all the traffic flowing with him. Okay, this is the goal, basically, the main goal. So the man in the middle can be passive or active. That attacker can just forward the traffic back and forth, okay? Or it can be active where the attacker changes the traffic for a particular purpose. It is very common on networks, and here we will see ways to do this, man in the middle. Replay attack, we saw it. So replay attack, capture some packets, replay them later. Okay. So attacker captures the data, resends the same data later. A simple attack capture passwords and save them, Yeah, of course. If you know that certain 3 or 4 packets contain the password, you will store them and replace them later to get access. DNS poisoning. Now here I think the 3 next attacks are about DNS. So DNS, you know, DNS protocol, it maps domain names with IP addresses. So you have the domain name, you need the IP, you use DNS protocol for that. Okay. So basically here, if the mapping between domain names and IPs is compromised, basically you can redirect legitimate users to malicious websites. Okay, the legitimate user will ask for gmail.com. If you can manipulate the DNS mapping, it can be forwarded to a malicious or attacker's IP. Okay, so the goal of DNS poisoning is to change that mapping. So here, if the user asks for the IP of a certain domain, okay, if the attacker can replace or can change that mapping, this is basically DNS poisoning. So this is the idea. But how this can be done? It can be done by locally changing the local DNS file in any OS. You have the DNS file. It's not the cache here. It's not the cache. Okay. It's a set of static mappings which is stored. For example, in Windows, it's in this host file. So you can open that host file and you see some mappings between IPs and the domain name static. Okay. So if an attacker can go to that host file and replace the IPs with malicious ones, this is basically local DNS poisoning. DNS cache poisoning. Now, DNS cache poisoning, of course, DNS is not done for every request. Okay. If you go to gmail.com, you don't know the IP. You don't know the IP. So you send a DNS request, you get the IP. Okay. You do it once, but the next time, after the next packet that you need to send to gmail.com, you will not repeat the same DNS process. You will cache it for some time. Of course, it will be refreshed regularly. Okay. If the attacker can poison that cache, change the content of that cache, okay, he will be able to do or to redirect the attacker to some other IPs. So here, this is a typical scenario. The user asks for the IP of certain domain. The server, the DNS server, will answer by the valid one, the correct one. But now the attacker, he can, seeing that the user asked for a certain IP of a certain domain, he will flood it with wrong mapping. Okay, flood it. Basically, he will send a lot of responses. So the user will ignore the valid one and will consider the false one. Okay.
There is no protection for this.
DNS is not secure by design. Okay. So now there are protections.
In operating systems, I mean, there are so many replies. This means
in the original version of DNS protocol, it will not protect against this. Okay. So you need to add some protection. This can be protected by having signatures, patterns of this behavior, and you can alert. But the problem, we're gonna see it, is whenever you use this detection mechanism using signature, always you have this trade-off. You can have false positives, okay? Meaning that you might have a situation where this is valid traffic, okay, and it will be detected as malicious. So whenever you have these detection features, it will have some side effect. Okay, so
this you have primary and secondary DNS server. So we only respond. We should only accept messages or information coming from those two.
It can be, see here, DNS cache poisoning, if it is mentioned here, it means it works. It works, okay. If you restrict to the DNS, DNS traffic to two IPs, like primary and secondary DNS servers, probably there are limitations to this. Okay, this is why you need to leave it open somehow. Okay. Sending extra DNS records. Another trick to poison the DNS. Okay. So here, this is the user. He is asking for the IP of good.net. Okay. So he will contact a DNS server. The DNS server, basically here, the DNS server. It will contact some other DNS server for another address, like evil.net. Okay. Now the scenario it's because you know when you have a DNS server, it doesn't have the IPs of every domain. It needs to contact its hierarchy of DNS servers. Okay. Like you said, primary, secondary, etc. So here, the goal of this attacker is to make this user believe that good.net is this IP. Okay, so what it does, it waits until the DNS server asks for its own or another address that this DNS server has, and instead of just answering with evil.net IP, it works with extra IPs, extra mappings. The goal is to change the mapping view. Okay. So basically, this server asks for one IP. This malicious DNS server will answer by extra mappings to change the mapping here and then the IP that is received by this good user. Okay. Yes.
How will the attacker make the valid DNS contact to request from the IP address?
You know, here, see, this is the attacker's computer. Okay, so it is asking for, it's contacting the same DNS server. Okay, and it is forcing that DNS server to ask for the IP of this event. You see? Yeah, it's a complete scenario.
Yeah, because also the IP address.
It's a different target address, but in the end it will poison the other.
Yeah, the goal here is to make this user believe that the IP of this good.net is that malicious one. Now, the most common type of man-in-the-middle attack is ARP Cache Poisoning. So ARP protocol is the address resolution protocol. It maps what? MAC address with the IP address. Okay. So if you this ARP protocol works as follows. So this user needs to communicate with some destination like this. Okay. So it will broadcast a message saying who has this IP. Okay. And normally everybody will discard that because they don't have that IP. Only the destination will respond with its IP, so it will say, yes, I have that IP and this is my MAC address. Okay. Now this is how it works, normal scenario. Now the attacker, if he wants to make the victim, or the user, believe that he has the IP address of this one, he will flood that user with wrong mappings. Wrong mappings, so it will say, yes, I have this IP and this is my MAC address. It will repeat it several times, so the user will ignore the valid one and will consider that. Same thing, the same trick as DNS cache poison.
But this is only local. I mean, you have to be inside.
Yes. This is local, yeah, because ARP is in a local area. Yeah, ARP poisoning is known. It's local network attack.
All this traffic should be encrypted actually.
Should be, but ARP is really not secure protocol. Now there are secure versions of ARP. Yeah, so I want to show you first an example of denial of service. So it uses a tool. It uses a tool that is used by Anonymous a couple of years ago. Okay, Anonymous hacking group. Okay, they were using a tool called Loic, and now they have a list of tools. That means they are still using Loic, but there are also they are using a couple of others. So I think 6 or 7 years ago it was the main tool for denial of service. So basically, if you want to participate in this distributed denial of service targeting a particular victim, so you will receive the software, you will install it, and then you will agree on a certain time, and everybody will target the same victim at the same time. Okay, so. Like this is the tool. So this is the tool. This is the interface. Oops. Yeah. So this is the tool, and basically here it's very simple. The interface is very simple. So here you need to target one victim. Okay. So you need either his URL or his ID, okay, one of these, okay. Let's target the other machine here. 3. So this one is at IP. So 192.168.1.101. Okay. So you go here. You type in that IP, 192.168.1.101, okay, and then log on. So the target will be fixed, okay, and then you have a couple of configuration here. What you can do, so you can choose the speed of the attack, okay. So here faster, speed, slower. So because it's sending a lot of packets very quickly, and you can make it either slower or faster. Okay, you can pick the method, either TCP or what kind of packets you're gonna send. So TCP, UDP, or HTTP. Okay, and then you pick the destination port. Okay, you pick the number of threads. Here by default there are 10 threads. So in addition to the speed, you can use it. You can do it in using several threads. Okay. Then whether you wait for a reply or not, this is an interesting feature. Append random characters to the subside or message. So here, normally, a lot of firewalls are configured to stop denial of service, because if they receive the same packet several times, very quickly in a short period of time, they will block. Okay, so here, if you have in front of you one such firewall, you can change the content of the packets random. So in every packet, you will place random data so that they will look different. Okay. So let's make it here 100 thread, and here keep it faster. And then if I go to the destination here, I will. I will launch Wireshark to see how the packets are coming. Okay, and then so now it's capturing, and then I will open the task manager. So here we can watch out the network, all the performance and the processes, etc. Okay, so let's launch the attack. So here, and then here I'm charging minus. This is the done. Okay.
So we are now requesting 700.
It is counting, yeah. So requested 3,000. It's not that slow because it's the machine. It depends on the any capabilities of the machine. So if we go with the other victim, yeah, see here the traffic starts to go up. Okay, and here 64,000 packets, 68,000. This is an attack launched by with just one machine. If you go to the performance, see here it's 80% already. Okay, and those 80% because of one shot. Okay, because it is processing all those parts. But here we are targeting port 80, which is the server. So if you have a server running, it will process also those packets. So you will have a similar. See here, 100%. 150, so 60, etc. So the resources are quickly exhausted. Yeah. So let's stop this. Okay. Stop floating. So it sends 180,000 packets. Okay. So. Yeah. So next time we will see all examples of all those another attacks like DNS poisoning, ARP poisoning, man in the middle, active and passive. So we'll see examples of all these, and we'll start the detection. Yes, detection technique. Because all these I mentioned now, different types of network attacks. Next time will be how to detect it. Okay. Yeah, that's it. So see you tomorrow.